Same page, problem number 50, page 56. This is problem number 12. It reads x minus 1 parentheses times cosine y dy equals 2x sine y dx. Alright, by the way, I should have mentioned in the last video that it would be great if we could solve for y in terms of x. In the last problem, that would have required doing the quadratic formula. It would have been kind of messy. But we don't always have the luxury of being able to easily solve for y. So that's why the problems in this section, a lot of the answers have x's and y's mixed throughout the equation because it's not easy to solve for y. Okay, well, again, this is really an exercise in integration, and so it's kind of ordinary calculus in disguise. We just have to do a little bit of algebra to separate x's and y's. So I'm going to bring the x terms over and the y terms over. So I would divide both sides by x minus 1 and divide both sides by sine y. So this gives me cosine y over sine y dy on the left side. On the right side, it's going to be 2x over x minus 1 dx. Alright, yep, that looks good. And further finesse is that cosine over sine is the cosecant. So we have, cotangent. Cotangent y dy is 2x over x minus 1. And I'll tell you what, let's separate that. No, we can't separate that. Never mind. Okay, 2x over x minus 1, and then dx. I'm looking at this and kind of drawing a blank on how do I integrate this? Because see, at this point we can integrate both sides. And how do you integrate 2x over x minus 1? Okay, well, there's I can think of two techniques here. One would involve dividing x minus 1 into 2x minus 2x, and let me just show you that technique. This may not be the best way to do it. So if I divide x minus 1 into 2x, x goes into 2x 2 times. Multiply 2 times x minus 1, I get 2x minus 2. And then we subtract. This is long division. We subtract, and I get a 2. So this is plus 2 over x minus 1. Okay, that's one thing we could do. So we could rewrite this as the integral of 2 plus 2 over x minus 1 dx. And to me that looks easier. Okay, now because I can integrate 2, and I can integrate this and get a logarithm. The other technique would be to I'll just show it down here, let u be equal to x minus 1 as a substitution here. That means that x would be u plus 1 and du is equal to dx. So if I did that substitution, then this integral becomes 2 times x would be 2u plus 2, 2u plus 2 over u du. Okay, which is the integral of 2 plus 2 over u du. Alright, they're basically the same thing, because if you went back, this is x minus 1 and du is dx, it would work. So there's two techniques for doing that, and this course will improve your integration techniques, integration skills, by giving you yet more practice at that. Alright, I think I'm going to go ahead and do this part here. So let me erase the bottom. And I'm trying to remember what the integral of cotangent is. I know the integral of tangent is It's a natural log, isn't it? I'm going to look it up because I'm not too confident in my memory of all these integrations. Alright, so I'm going to my calculus book, and the integral of cotangent is a natural log of the sine function. Okay, that's good. Natural log sine. So, natural log sine y is my left side when we integrate. The right side, we're going to get integrate 2 dx, we get 2x plus, and this is a logarithm. It's 2 natural log absolute value of x minus 1. And because it has the dx over x form, and but it's pretty easy to verify that if you take this derivative, you'll get 2 over x minus 1. And then we have an additive constant, plus c. And we have a mess. And so let's do a little bit here. We can let's bring this logarithm over here. So I've got the natural log absolute value sine y minus 2 times natural log absolute value of x minus 1 equals to 2x plus c. And here this gives us a chance to review one of the properties of logarithms. When you subtract logarithms, 2 logarithms, you can combine them into a single logarithm by division. So that gives me the opportunity to combine these together. This is the natural log of sine y divided by, well, what's it divided by? It's divided by x minus 1 squared equals 2x plus c. I'm going to switch to black ink because my blue pens are getting kind of faded. So the other thing is that the 2 in front can become an exponent here, and I'm subtracting, so it's a division, and I still have absolute value around the sine function, but since I'm squaring x minus 1, that's basically takes care of the absolute value.